All right, hey guys, it's Mrs. Van Newland here. We are going to go over how to rewrite numbers in scientific notation. And then I'm also going to show you some tricks if you want to change numbers when they are written in scientific notation, if you want to change them a little bit. So just as a quick reminder, a number is written in scientific notation when it's a number between 1 and 10, like maybe 4.5, and then times 10 to some power. So that number is in scientific notation. This number, 0.24 times 10 to the fourth, this is not in scientific notation because that's not between 1 and 10. All right, before we get started, I need to show you something because we are going to be using this today. Let's say I give you the number 5 and the number, let's just say 8. Okay, what do you think would happen to the number 5 if I times it by 10 and then I divided by 10? So if I took 5 and I multiplied by 10, got my answer, and then I immediately divided that by 10. What do you think might happen? Well, let's see. So if I do 5 times 10, that gives me 50. And then if I divide it by 10, it brings me back down to 5. Okay, let's try it with the 8. Let's say I times by 10, and then 8 times 10 is 80, and then I divide by 10. 80 divided by 10 is 8. Okay, so it gets me back to the very same thing. So today we are going to actually be multiplying and dividing by 10, which will help us realize that we're not actually changing the number. If you times by 10 and divide by 10, the number is still going to stay the same. We're going to use that today. All right, let's take a look at this first one, 58 times 10 to the third. Right now, this is not in scientific notation. So I need to change it to scientific notation. So the decimal right now is right after the 8. I need to move it back a place. So now it will become 5.8. All right, that's between 1 and 10, so that's good. Now, when I'm actually moving the decimal back a place, I'm making it smaller. I'm dividing by 10. Now, if I divide 58 by 10, that's changing the number. I can't really change the number. I still need to keep it the same number. So over here, I'm actually going to times by 10. Now, that'll work because I showed you guys on the last slide that if you divide by 10, but then you immediately multiply by 10 or vice versa, it doesn't change the number. So let's look what happens here. This is really the same as saying 10 to the first. So 10 to the third times 10 to the first is really the same as 10 to the fourth. Now I just rewrote that number in scientific notation. Okay, let me show you another one. So right now, 27.2, not in scientific notation. Okay, I want to change it, so it is. Okay, so I can move it back one. Remember, I'm making it smaller because now it's 2.72, so I actually divided this by 10. If I divide by 10, I need to multiply by 10 over here, so it stays kind of the same. I'll put a little 10 to the first. Now I'm going to use my laws of exponents. 10 to the fifth times 10 to the first is 10 to the sixth. Now I just rewrote that in scientific notation. All right, before we get to some with negatives, I want to show you guys a little trick. This is how I'm going to go through it the rest of the video. All right, this number is not in scientific notation, but to make it, I move that over. Now, when I go from 45.6 to 4.56, I just made that number smaller, okay? And I moved it over 1, right? If I make that number smaller, I need to make this number bigger. And to do that, I am going to, because I only moved it over one place here, I am going to add 1 to the decimal. So if this number becomes smaller, this has to become bigger. And I only moved it once here, so I'm just going to add 1 here. So that's going to become 10 to the fourth. Okay, let me show you that same thing on another one. Okay, this time I need to move it over one spot here. Okay, now I just made this number bigger. Okay, if that number becomes bigger, this number over here I need to make smaller to kind of do the inverse operation. So I'm going to, instead of adding 1, subtract 1 from that exponent. And I only do 1 because I only moved the decimal over one place. So it becomes 4.5 times 10 to the fifth. And now I just rewrote it in scientific notation. All right, let's go ahead, try 2 more. You guys can try this on your own if you would like. Otherwise, just go through it with me. So this one, I am going to move over 1, 2, 3 places, it looks like. And I just made this number bigger. Okay, if I made that number bigger, it went from 0.003, now it's 3, times 10 to the, I moved it over 3, 1, 2, 3. That became bigger. Over here, it needs to be smaller then. So since I moved it 3 places, I'm going to subtract 3. Now be careful when you do this. I'm going to add the opposite here, and it really ends up being 10 to the negative fifth. And then there is my answer. Okay, let's look at the bottom one. Okay, on this one, again, I'm going to move it over 1, 2. I just made this number bigger. If I made that number bigger, I need to make this one smaller. And I moved it over 1, 2. So I'm going to subtract 2. Okay, I end up with 1 times 10 to the negative 5th. Again, I'm going to add the opposite there. And I end up with 1 times 10 to the negative 5th. All right, so just a couple notes you might want to put in your notebook when you're working with scientific notation. If you're changing the number and you make the number bigger, okay, you need to make the exponent smaller. Okay, so you might want to write that down. If you make the number part smaller in the problem, then you need to make the exponent bigger. And again, I showed you why that worked when we were multiplying and dividing by powers of 10. So those are just a couple quick notes. All right, now we are going to be getting to some problems later on in this unit when we're multiplying, dividing, adding, and subtracting. We're going to be getting to some problems where you actually need to change numbers so they're not in scientific notation. And you'll kind of see why eventually, but for now I just want to kind of show you this. So I want us to work on changing this number to the indicated power. Okay, we want to change it to the 4th power. Right now it's to the 3rd. It is in scientific notation, but I want to change it to the 4th. And again, there will be a reason for this later. I just want to kind of point it out now so we know how to do this. All right, so right now, again, it's to the 3rd power. I want to get it to the 4th power. So let's just kind of, I'll show it like this. I'm going to add 1 to get it to the 4th power. Now, if I made this bigger, I need to make this other number over here smaller. Okay, and it was just 1, so I'm just going to move it smaller by 1 power of 10. So I end up with 0.452 times 10 to the 4th power. Now again, this isn't in scientific notation, but later in this unit, you're going to see why. Sometimes you might need to change a number so it looks like that. Okay, let's try this one. I have 3.75 times 10 to the negative 5th. I want to change it to the negative 7th power. All right, so to get this exponent to be negative 7, I need to subtract 2. Because negative 5 minus 2 more would get me to negative 7. So I just made this one smaller, right? Because negative 7 is smaller than negative 5. So I need to make this number over here bigger. Okay, so I did 2 places here, so I need to make it 2 places, 2 powers of 10 bigger over here, or times it by 100. I end up with 375 times 10 to the negative 7. Again, this is not in scientific notation. It's still the same number. These two numbers are still equal. Just 2 different ways to write it, and this is going to be helpful for us when we get into adding and subtracting numbers in scientific notation. All right, let's try another one. We want to change this one to the 7th power. Okay, so pretty easy. I need to add 4 here. Or this is actually the same as saying, I'll just write it out another way here. Right now it was 10 to the 3rd. I need to times it by 10 to the 4th so I can get it to be 10 to the 7th. Okay, so that's really why that works. I'm not just adding a random 4. I'm really doing multiplying by 10 to the 4th. So over here, I need to make this one smaller because I made this bigger. Okay, by 10 to the 4th, I need to divide by that. So I'm going to move it back 1, 2, 3, 4, put some zeros here. So it ends up being 0.00056 times 10 to the 7th. So I rewrote that so it was in the 7th power. Okay, why don't you try these two? Push pause, see if you can rewrite these two. The first one so it's to the 1st power, and the next one so it's to the negative 2nd power. So pause the video, push play when you're ready to see the answers. All right, so this first one, I want it to be to the 1st power, so I need to subtract 2 here. Okay, if I made this one smaller, then I need to make this bigger over here by 2 powers of 10. So I'm going to multiply it by 100 or move it over twice. So I end up with 420 times 10 to the 1st power. Okay, and then this last one, I want it to be to the negative 2nd power. So I'm going to have to add 3 here. Okay, so I made this bigger. So this needs to be smaller over here. 3 times 1, 2, 3. That's really like dividing by 1,000. 1, and I end up with 0.0053 times 10 to the negative second. All right, last thing I want to do is show you how you can test to see if you're actually right. So I'm going to start with the original problem. It was 4.2 times 10 to the third. This is one that we did. I'm going to change that to standard form, to a normal number. So 3 spots, I'm going to move over 1, 2, 3. So this number is really 4,200. That's a comma there. Okay. Now my new number that I changed it to was 420 times 10 to the first. Okay, well, to change that to standard form, I'm going to move my decimal 1 spot, so just 1 spot, and that changes it to 4,200. So these numbers are both equal, so I know I did it correctly. So that's a way you can check. You can always change both of your numbers to standard form, see if they end up equaling the same number. All right, if you have any questions about how to change these numbers, please reach out to your teacher.